Alright, your warm-up today. There are 3 different colors of gumballs in a package, but not the same number of each color. Use the given probabilities to find the missing probability if you know there are 24 gumballs in the package. Dion, what do you have for our first one?
13 over 24.
Almost.
What?
You're not wrong, you're just not done. Dylan.
11 over 24.
11 over 24. Is that chat, Steven? Okay, so why was Dion almost there? Steven. He said 13. What is 13? You don't know?
13 is the probability.
Julian?
Yeah.
Okay, so it's what we already have. Okay, so you were on your way there. So here we have 5 out of 24 red. 1/3 can be rewritten as 8 out of 24. So this is 13 out of 24. That's what we already know. So what's missing is what's my green. Yeah, you're good. So 11, that means 11 out of the 24 has to be the green. All right, my next one. What do we think? Steven? 1/3? Nice.
My God, I got that one.
Good. So if anyone needs to see it, 1/6 we can rewrite as 4 over 24. Green of 1/2, we can say that's 12 over 24. So 16 out of my 24 is there. We're missing 8 of my 24, which simplifies to 1/3. Yeah? What's up? Yep. You're good. That's another way to do it. Yeah, so she just converted 1/2 to 3/6. So you got 4/6, which reduces down. Yep.
Oh my God, we have a quest this week.
We do have a quest this
What's that
week.
mean?
So a quest, it's a test grade, but you get to use a cheat sheet. So you get the benefits of a quiz, but it's going to be counted as a grade, as a test grade in the grade book. So there's lots of stuff happening with probability. So I feel like having that note card, cheat sheet, would be beneficial. So, okay, ready to move on to overlapping and disjoint events today. And then tomorrow we'll do combinations and permutations. And then we'll start getting ready for our quest this Friday. All right, first off, so we're going to do Venn diagrams today. When you consider only the outcomes shared by both A and B, you form the intersection of A and B, as shown in the first diagram. So when I want A and B, we're looking at their intersect. Okay. Similarly, when you consider all the outcomes that belong to A, B, or both, there's a key word there, we're forming the union of events. Okay? So intersection comes from the word and. A union comes from the word or. It just has to be in a circle. It could be this or it could be that. They could share it, they could just stand by itself. Okay? And means it has to have both characteristics. Okay? It can't just be orange or a cat. An intersection would be an orange cat. Does that make sense? A union would be an orange animal or a cat. Would make up my data. There we go. The union or intersection of two events, or these two things, they are called a compound event. Okay. These are also called overlapping. Two events are overlapping when they have one or more outcomes in common. So that's going to be an intersection or a union. Those are considered overlapping events. Okay? So what if they don't share? Okay? They are going to be called disjoint or mutually exclusive when they have no outcomes in common, as shown in our third diagram. So this is our disjoint. Okay? There is nothing in common between the two. So if my circles were overlapping, that middle section would be empty. Okay? There's nothing that they have in common with each other. To find the number of ways that A or B can occur, we count the number of outcomes in the union of A and B. So to find the number of ways A or B can occur, we count the number of outcomes in the union. So if it's in the circle. Okay? So again, A or B, that word or, means we count whatever is in a circle. Okay? As long as it got placed somewhere. So let's do a couple examples of determining if it's overlapping, if it's disjoint, and what happens if we don't fall within a circle. Okay? We spin the spinner. It's numbered 1 through 12. So we have two parts. Determine whether the events are overlapping or disjoint, and then find the number of ways in which A and B can occur. So I'm going to figure out what is it, and then this piece, I'm going to add up everything that got put into a circle. All right? For our first example, we're going to spin an even number for event A, and then we're going to see if we spin a multiple 3 for my event B. So I'm going to label my circles A, B. So let's go through numbers 1 through 12 and see where it falls. Okay, the number 1, is it even?
No.
No. Is it a multiple of 3? No. So can I put it in a circle? No. So we just put it out here in space somewhere. Doesn't matter where, just out in space. All right, the number 2, is it even?
Yeah.
Is it a multiple of 3? No. So it just goes into event A. Number 3, is it even? No. Is it a multiple of 3?
Yeah.
Yeah, so it comes over here in event B. Number 4, is it even? Yes. Is it a multiple of 3? No. Number 5, is it even? Is it a multiple of 3? No. Toss it out somewhere. Number 6, is it even?
Yes.
Is it a multiple of 3?
Yes.
Woohoo! We finally have something that goes in the middle. You do the rest. Figure out where 7 through 12 is going to go. Check your numbers with mine. Make sure they match up. Would you say this is overlapping or disjoint?
Overlapping.
This is overlapping. Good, because there is an intersect. So that was part A. It's to determine if it's overlapping or disjointed. This is overlapping. And then part 2 said, find the number of ways in which A and B can occur. So for that, I need to see what falls in a circle. Okay. The numbers that got put into event A or event B were the numbers 2, 3, 4, 6, 8, 9, 10, and 12. So how many ways could A or B occur? 8. So part 2, we're answering there are 8 ways for event A or B to occur. What if it wanted to know how many ways could A and B occur?
2.
Then you would just say 2. Good, just the 6 and the 12. All right, think you can handle the next one? All right, you try the next one. All right, make sure your numbers match mine.
Steve Slow, get it.
Are we overlapping or disjoint this time? We are disjoint because they have nothing in common. Between the numbers 1 and 12, there is not a number that is a factor of 10 and a multiple of 4. All right, part 2. It wants us to list the union, okay, of event A and B. Okay, so what are the number of ways A or B can occur? So that is anything that is in a circle. Okay, that is anything in a circle. So what numbers got put into a circle? 1, 2, 4, 5, 8, 10, and 12. So this is the union technically, if you want to put your vocab on there so you know what you're doing. So how many ways could this happen? 7. Good. 7 ways for event A or B to occur. Good. You like Venn diagrams?
They're all right.
Cool, now I'm going to take them away.
What? Why?
I know, that's why I have to take it away.
I thought you were
So Venn diagrams are a really good visual, okay? So now when we step up, you could probably create a Venn diagram like in your head. Venn diagrams are really good if you have every piece of information of what actually occurred,
So now you're
right?
about to be like,
But sometimes we just get the end result, right? It's this percent of this happened or something like that, okay? Or maybe it's too much. Like if we're looking at a blah, blah, blah. Looking at a deck of cards, right? How many cards are there in a standard deck? 52. I don't want to categorize each 52 card, right, to be in a circle. Do we agree?
what?
Yes? I'm not going to put that in the Venn diagram. I'm not going to place each one in a circle, if that makes sense, okay? So what's going to happen is we're going to have equations to help us out, okay? If A and B, let's find the probability of an outcome that is in the union of A and B, written as A or B, remember that means anything in a circle, you must consider the number of outcomes in the intersection, okay? If A and B are intersecting, okay, we have to add up each circle together, but then subtract the intersection out, okay? Let's go back up here and see why I have to take it out, okay? If I added up all my numbers in circle A, how many numbers are right here?
4. Well,
Technically, there's 6 numbers in circle A,
and there's also,
right?
There's also,
And then if I add up all the numbers in circle B, there's 4 right there, right?
yeah.
6 plus 4 is 10. But we said the union was 8. Because what happened? Yeah, we double counted 6 and 12. So when I don't have the Venn diagram to pick and count each piece individually, okay, we can add my 2 evens together, but then subtract the intersection out so we don't double count something. All right? If they are disjoint, does that matter? No. Look here. If I do, there's 4 in circle A. Over here, there was 4 in circle B. 3, thank you, in circle B. 4 and 3 is 7. There was no overlap, so it was okay. All right, so there's nothing to take out. You could like say minus 0 if you wanted to. But if it's disjoint, you can just add the 2 pieces together. All right, so let's set some examples to do this without having Venn diagrams. We are going to be looking at a deck of cards for example 2 and example 3. Okay. A card is randomly selected from a standard deck of 52 playing cards. So let's pause right there, because some people today aren't sure what's in a deck of cards. So here it is. Okay. There are 4 suits. There are spades, clubs, diamonds, and queens. Hearts. Queen of hearts got in my head. Spades, clubs, diamonds, hearts. There we go. And then each of those suits have the cards ace through 10. Aces are considered ones. And then you have face cards, jack, queens, and kings. Okay? They're called face cards because they have faces on them. I know. Shocking. Okay? So this one will be disjoint because we can't get a 10 face card. It does not exist. So that means to figure out if I'm going to get a 10 or a face card, I can just add up probability of picking a 10 with the probability of getting a face card. Okay. So out of our 52 cards, how many of them are 10s? There's 4 of them, right? Bless you.
Bless you.
Out of my deck of cards, how many of them have faces? 12 of them have faces. Good. These guys right here. See how when I marked on my paper, they did not overlap? Oh, disjoint. So my visual friends, that'll help you out on Friday. Okay. So we have 12 face cards. So how many total cards are there? There were 16 out of the 52. That's going to be a 10 or a face card. So what is that probability going to be?
42%.
Probability of 10 or face is going to be 0.308. So we can say about 31% or about 30.8%. All right, ready for our next one? Yeah? All right, my next one is talking about, let's see what we have here. A card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a face card or a spade? This one's overlapping, right? If I look at my deck of cards, do I have some that's face and spade? Yeah, there's 3 of them, right? We have 3 spade face cards. So this one is going to be overlapping. We have 3 cards. 3 cards are a spade and face. Okay. So to find the probability of face or spade, we're going to do probability of face plus the probability of a spade and subtract the overlap of face and spade. Because when I add the 2 together, we're going to double count those. We already know it's 3, right? Those 3s are going to get counted twice. All right, so let's look at it. What is the probability of a face card? That's first. There was 12 that are face cards. Okay. How many spades do we have? 13. You could do 52 divided by 4. Or you can count 1 through 10 and then Jack, Queen, King because it's 13 cards. So see how the original 3 that I circled, they're in the overlap between my face and my spades. Okay, so our math is making sense. So we have 13 spades. So 12 plus 13 minus 3 is going to give us, there you go, 22. So what is our probability of selecting a card that's going to be a face card or a spade? About 42.3-ish%. Or 42% would be acceptable. Questions? Yes. Card questions are very common when it comes to overlap and disjoint because so many could be one or the other. Yeah, so cards is a good example. That's why I'm gonna print this. So I don't want, because some people don't have this memorized, which that's not part of the standards, memorizing a deck of cards. So yeah, I'll provide this picture for you so that way you don't have to question that. But yes, we like cards. Lots of stuff you can do with cards. Okay. Ready to apply this to real life? Yeah? Anybody watch Bones? One of my favorite shows. Nobody? Oh, y'all need to watch it. It's wonderful. Okay, well, she's an archaeologist. Technically, just her specialty is bones. An archaeology lab receives 150 artifacts for processing. Of those, 108 are either made of clay or have coloring. There are 81 artifacts made of clay and 34 artifacts that have coloring. What is the probability that a randomly selected artifact is made of clay and has coloring? Okay, so let's look up the information that's been given to me this time. We have 2 facts about my artifacts. Okay, event A could be that it's made of clay. Event B could be that the artifact has coloring on it. It wants to know the probability that both are happening. Okay. So I can use our formula from earlier because they also told me the or. So I know just coloring, I know just clay, I know coloring or clay. So I can use those 3 to find the missing piece of coloring and clay. So it's the same equation, just a different piece is missing this time. Okay. So what do we know it's overlapping. Okay. So the probability of clay or coloring is going to equal the probability of clay plus the probability of coloring minus the probability of clay and coloring. Okay. How many artifacts are there? There's 150 artifacts, right? This is what we don't know. So we're going to fill in everything that we have to be able to easily find what I'm missing. Okay? How many artifacts did they tell us have clay or coloring?
108.
108. Clay or coloring. Good. Okay. Event A by itself, how many are made of clay? 81 have clay. Good. And then how many have coloring?
34.
34 have the coloring. What is 81 and 34 together?
115.
115. So 115 minus how many have clay and coloring equals 108. So how many artifacts have clay and coloring? 7. So 7 out of 150 are made of clay and have coloring. That wasn't the question though, was it? So we're not wrong, we're just not done. If we know 7 of them have it, the probability of that, we divide out of 150. What'd you get?
4.67%.
About 4.67% or 4.7%?
Yeah.
0.047.
Also, how does there was